We started from Friday. We said, don't want to touch that yet. It's too hot. Too hot. All right. Why? We need to put it in order, right? So make sure the exponents go from highest to lowest before we start touching it to factor. All right. From there. Hi, Brett. Unbelievable. GCF. Don't touch anything until you've done look for a GCF. And there is a GCF here. First, let me start with the 8, the 60, and the 32. Highest number. I know you could pick a 2 out, but you really want to pick the highest number. Jenna, thank you. 4x. Now, I don't know what you guys feel. My preference always, I never like that leading term to be negative. So yeah, you could take out a 4. My preference, -4. Everyone all right with that? All right, I don't want to confuse you, so I take out a -4, and they all have what in them as well? They all have an x in them, right? So I can take out an x. All right, now just watch yourself because you did take out a negative. What would this become here? 2. Now, if you're unsure, hey, all you guys are doing when you take GCF, have you realized you're dividing? That's all you're doing is dividing. So all I'm doing is -8 divided by -4. Hey, that's a +2, and I have x squared left. 60 divided by -4. -15x. And then 32 divided by -4, -8. So when you're taking out a GCF, you're really just dividing, all right, if you lose focus. All right, now, keep it going. You can probably do something inside that parenthesis, and we talked to you. How many terms are there? 3 terms. What's the number out in front, the a value? 2, so I can't do multiply to 8 and add to -15, right? I can't do that. But I can try to what instead we did on Friday? What was the method we did on Friday? Name? Hi, Alex. What's that? You're right, but what's that called? You're doing. What's that whole process called? Grouping. All right, I can try to group this. All right, so what I'm going to do here, you said to do what first, Alex? Multiply and give me -16. Nice job. So now what I want to do here is I want to take that -15 and break it up into 2 terms. Please don't get confused. Guys, take a look real quick because this gets confusing every year. This stays the same. The A value stays the same. C value. You are not changing that. Do not plug a -16 in here. The only value you are changing is the middle one. How? I need 2 terms that multiply to -16, but when I combine them here, they're going to go back to -15. So 2 numbers that multiply to -16 but add to -15. Ashley, thank you. I'm getting there. Say that again. -16x and plus x. Does everyone see why those would work? Go ahead, combine your like terms right now. You go back to -15, multiply them, and you go to -16. And now we can group it, because how many terms did you just make it into? 4. Group them. All right, here you go. These 2 and these 2. What can you take out of the first pairing? I can take out a 2x, and I'm left with x minus 8. Everyone all good? What can you take out of the next one? Yep, great. No, don't tell me nothing. That's not, 1 is the correct answer there. So take out a 1 and show me you're taking out a 1. And you're going to be left with whatever's just still inside. All right, finish the grouping. You have 2x plus 1, and what goes in the other parenthesis? X minus 8. I did this on purpose. Mine's not correct. Art. You gotta bring down the negative. Darn right you do. -4x. Bring it down. That is fully factored. Anything else? We okay on that one? All right, and then you guys had, not out of the book, but out of the textbook, basically just mimicked your notes. I don't know if you saw that. What's up, Brett? Where are we going? Oh, sorry. Ready.
So we have like +1 right outside the parentheses, the second to last step.
Yep.
And we bring it in the parentheses. What I did, I don't know why, but I just put like an addition sign between the two parentheses.
It's got to be all multiplication.
It does.
Yep. When you factor, what's between the parentheses should always be multiplication. Okay? All right, because again, what was it? Look up here. Look at this step right here, Brett. What's in common? The left of the parenthesis and the right of the parenthesis. What's in common? So here's my plus sign, right? So the left and to the right, what do they both have in common? So that's my GCF I took out. And then you take out an x minus 8 and an x minus 8. What's left? 2x plus 1. Okay. Anything else from this question? Good question. Going back, how about anything from, hi, Jenna.
Can you go over linear functions, please?
Linear factors?
Yeah.
Okay, so you ended up factoring that, or proving, you did your, so you ended up, yep, here we go. You ended up doing this right here, right?
Yeah.
Okay, however you triple grouped, hopefully over on this side. This is what you ended up with, all right? Each of these alone right now is a linear factor because the highest exponent is 1. So that one is a linear factor. This one is a linear factor. Now, so is this one, but because it's squared, it happens twice. Because, if he told me to write it all out, I'd write x plus 2 twice. So 1 linear factor, 2 linear factors, 3 linear factors, and then a 4th linear factor. Okay? And again, why is it a linear factor? Because the highest exponent inside is a 1. Okay? You good? So there's 4 total. Good question. Oh, here we go. Lily, got it? Number 6. Okay, ready to group with me? What'd you do first? Yep, and you got negative 36. Like it? So now what I'm going to do, I'm going to turn this 3 terms into 4 for us. So I'm going to go 3x squared. Keep that the same. The only thing that's changing is the middle term, still minus 12. Don't put the 36 in there. Okay, everything is staying the same. So what we need right now, numbers that multiply to negative 36 but combine to give me a negative 5. What do you got? So negative 9. Now what did you put first? Because you could put them any order, but. So you did minus 4x. Yep, you're right. So plus 4x minus 9x. Good? And you grouped them, the first 2, last 2? All right, just want to make sure I'm doing it the same way you did. So I grouped the... Okay. Makes it easy on me. Thanks. No, thank you. Name again? Ashley. 8. Ashley. Yep. So you worked, I'm hoping you started working on the left side to make it look like the right side? Okay, so you, oops. Okay. Okay, so you triple grouped? I don't see any GCF, so, all right, so what'd you take out of that first grouping? Got it, and what were you left with? Okay, what'd you take out of the next grouping? And what were you left with? Good, I like your x plus 3s here. I'm going to run over my dotted line, but that's okay. And what'd you take out of the next one? Yep, and what were you left with? Perfect, because look what I'm left with inside the parentheses. All right, so you have x plus 3, right? And what are you left with in the next one? Yep. Does not look like the right side yet. We're getting there. So guess what I have to do with what's inside the parenthesis? Ready? How many terms? 3 is that value out in front, the a value 1? No, so I'm probably going to have to try to group it. Okay, whether you do that off to the side or right here. Ready? Here we go. 2 times 3, 6. So now we'll rewrite this as 2x squared something something plus 3. Can you think of any terms that'll multiply to 6 but add to 7? There you go. So plus 6x plus 1x, right? Group them now. So what can you take out of the first grouping? Yep, you're good. And what's left? Yep. And then what can I take out of this next grouping? Just a 1. And what's left? Okay, we're getting there. Okay, so I'd finish this grouping by saying 2x plus 1, right? Agree with me? And then x plus 3. But then I still have to bring down what did I already have originally? This x plus 3 right here, right? See where that came from? This right here, these two are from that grouping right here. And this x plus 3 is what I originally did when I triple grouped. Okay, and now, okay, how many x plus 3s do I have? So I can rewrite this as x plus 3 all squared. And there's my 2x plus 1. And look at that. We match now. Okay, and this was a tough one. All right, it was triple grouping. Then you had to group again on that trinomial. Yeah, good question. Hi, Brett.
Number 5, I got kind of stumped.
Stumped, huh? Even stumped you?
Yeah, stumped me.
Must have been tough, huh?
Not really.
It doesn't take much to stump you.
Yeah.
Okay, where'd you get stumped? At the very beginning, or?
I was like midway through the problem.
Okay, so you triple grouped.
I tripled.
Okay, so ready? You should have taken out an x squared on the first one.
I did.
And you left with x squared minus 4.
Actually, yeah, it was right there where I was just like, all right. So I did that whole thing. Like, I took out like the.
All right, so let me keep, you took out a negative 2,
Yep.
x, and was left with x squared minus 4. And then you took out a negative 8, and you were left with x squared minus 4. Okay, go ahead. Well, what's in common? All 3 of these have a what in common? X squared minus. Take them out. Ready? X squared minus 4. Take it out. What are you left with over here? X squared minus 4 is gone. What's left? Okay, ready? X squared minus 4 is gone. What's left? X squared minus 4 minus. Now you got some factoring to do. X squared minus 4, that can be x plus 2 and difference of 2 perfect squares. Right?
Yeah.
And then over here, 2 numbers that do what?
How can you make those 3 x squared minus 4 into 1?
Because it's a GCF. Ready? Here, watch. Ready? You tell me this. Ready? Good question. What are you going to take out of that, Brett? If I said factor and you're like, boom, GCF, what are you going to take out first? But there's 3 of them. Okay. They all have it. You're only going to take it out once. Right? Same thing here, right? They all had x's. You're only going to take out 1 x out of that. Same concept. You got x squared minus 4 3 times. You're only going to take it out once. Because all you're doing is GCF. Sure? Okay.
For number 7, I started doing it, but then when I got in the parentheses,
Did we have the what do you mean? It's not the same as my answer key?
no,
Oh, you mean grouping?
yeah.
Okay. Well, what would you do first, Lily? Okay, that's okay. Whoa, that's probably why. If you did that first, GCF, right? And just a suggestion, I'm glad you picked this one, Lily. Let's say Because now, okay, you take out an x, right? I would probably take out a negative x. Because again, whatever's out in front, I hate it to be negative. Okay? So yep, GCF, GCF, GCF. Anything else here? I love the questions, guys. Okay, if that means I get into today's notes and don't have time to finish, fine, that's fine. That's what's great about this class. We got a lot of time here until January. Anything from you guys? Last call? Go ahead, Ashley.
Just on the group ones, like in the picture, you have to write each step because on like the answer key it said like each step equals.
No, you don't. But at the end, once you get to one side equaling the other, just write down this step now, yes. Okay. No, just as long, Now, kids get clever on me, and they know it's supposed to look like this at the end, but they have no idea. They get lost over here, and all of a sudden, they match magically. I can tell. All right, good try, though, guys. Good effort. All right, I can tell what work needs to be done. Nothing else, because we're moving on to something totally different today. Totally different. We're all good? But I think it's something you did last year. The word undefined mean anything to you? Undefined? Good talk. Okay. We'll just stare at each other awkwardly. All right, here you go. Not much notes today because, like I said, I want you to get a group assignment done. All right, here we go. Day 3. Already day 3 together. Look at that. Oh, it is. I am just so fun. So fun. Ready to go, 5th period. And you guys are still all here, huh? No one's going to bail on me? I didn't scare anybody off first day. You're not going to bail? You're ready? Foot on the gas until January. You pass that Regents exam. And it's not an option. Everyone's passing. All right, a year and a half worth of material on that bad boy. All right, undefined. Anybody want to enlighten me when a fraction is undefined? Any little piece, anything going when it's undefined? When the denominator, top or bottom? Bottom. When denominator is equal to, you knew it. Denominator has to be equal to 0. All right. So what I'm looking here is what number can I plug in for x that makes the denominator all equal 0? All right. The first two pretty easy. All right. Next one, maybe not. So look at number 1 real quick. What number can I plug in for x where the entire denominator becomes 0? Can I plug a 1 in? What's 1 give me if I plug it in? Now, that's not going to work. What number can I plug in here and square it? That'll give me a 0. 0. So we say x has to be equal to 0 for that fraction to be undefined. No big deal. Okay. What about number 2? What number can I plug in for x that makes the entire denominator equal to 0? 6. You guys are good. No issues yet. Ooh, and then you get the 3. We may be here a while. Okay, if you start guessing numbers and trying to plug them in and see if it equals 0. There's a quicker way we can do this. What's in the denominator right now? Okay, x squared plus x minus 20. And what am I asking you to figure out? When that thing equals what? To be undefined. When that denominator equals 0. So set it equal to 0. And this is something you've done before. What can I do to x squared plus x minus 20? We've been spending 2 days on it. Factor it, factor it, factor it. All right? Can you figure out those two numbers for me? Here's where I'm going to start calling on you guys. Can you factor that? This is what I've been prepping you guys for. $17. I know. 20. What are your two numbers there, Michelle? They got to multiply to what? They got to add to 1 and multiply to Okay, got any numbers? Multiply to 20, one apart. Start thinking, good. Numbers that multiply to 20. Here we go. Spit them out. 2 and 10. Not going to give me a 1, right? Keep going. Closer to each other now. 2 and 10. How about 5 and? Give you a 1? They could. 5 and 4, where do the signs have to be? Remember, you got to add to 1, you told me. Got it. Nice job. All right. Keep going, because you have to tell me x equals this number. So keep going here. If x plus 5 equals 0, x equals -5. And x equals, it could be -5, or what else would work? There's 2 options here. +4. Okay? So both options would, if I plug them in, would give me 0 in the denominator. Don't care what's on top. Don't even look at it. I could put a darn happy face on top. Won't matter. You are looking in the denominator. Look in the denominator. What about 4? Ooh, I can't guess like I did for numbers 1 and 2 that easily. Hi, Brett. No. Don't look at you doing your poor classmates. No. Undefined just means denominator equal to 0, done. Okay. I see where you're going with this, but I could care less about the numerator. Yeah, I know. I get it. Don't worry. No, don't even bring that up to your classmates. All right, yeah. Don't get them nervous. Okay? Nothing to do with long division or synthetic division. No? Everybody remember that term? Yeah, well, that's a review for the Regents exam, so don't worry about it, kids. I care about the bottom. When is x cubed minus 16x equal to 0? That's what I want to know. Can you factor that? Come on, we've been doing it for 2 days. What's up, Art? Darn right. First. You always look for it. What is it? Okay. What are you left with? Keep going.
X squared minus 16.
Yep. Whoa. Easy, boss. Easy. You're just trying to show off now. Still can do what? Not done yet. There's still a little more factor in there. What else you want me to do here? 4, what else you want me to do? Go right ahead. What do you got? And? Oh, maybe I didn't hear you. X minus 4. Oh. You had the x minus 4. And then that's x and 4. But what do you know about the signs when you do difference of 2 perfect squares, Sarah? Opposite. So +4, right? All right. What are my answers then? What values of x are going to make this undefined? Ready? -4 turns into? So 4. And then if I have x plus 4, I'll also have x equals. But there's also a third and final answer. Not just these two. There's another number here. Nope. Remember you took out an x? Still have to set it equal to. So x equals. If you just said -0, get out. Get out. Good. Every time you have a thought, forget it, Brett. All right. Everyone good? Exactly. See, you're starting to learn already. Everyone all right? And ready? Hey, quick trick. I'm sure your teacher had to mention this last year. What was the highest exponent here? That should have many answers you should have. Anybody remember that? What was the highest exponent here? That's how many. See that, Mary? It's a pretty good trick. Did you learn that last year? Probably. Okay.
We did.
Okay, you did. All right. Whatever the highest exponent is, that's how many answers you should have. All right. Questions, comments, any concerns? All right, now that's undefined. Now to the big time. You guys reduce fractions in the past? Like if I said, hey kids, reduce 12 over 20 for me, could you? Could you? All right, you find the biggest number that goes into both and get after it, right? Okay, it's the same thing, except now we got variables. Okay, so take a look at my first one. First, are there any pluses or minuses? Addition or subtraction? That's what I'm talking. Are there any addition or subtraction signs? There's a negative. That's not count. Addition or subtraction signs? No. So you can reduce anything on the top with anything on the bottom. So let's start with the numbers now. Negative 2 over 8. What's that reduced down to? Negative 2 over 8. Negative 1/4. Everyone agrees? Okay. How many x's do you have on top? 4. How many on the bottom? 4. Guess what happens? See ya. They're gone. All right. Nowhere to be found. How many y's do you have on top? 2. How many on the bottom? How many are left? 2. But where are they going to be located? On the bottom, because that's where I had the 4. You just reduced your first fraction there. Congratulations. We okay? Questions? Okay, deep breath here before we get to 6. Whew. I can't reduce right away. Like I can't do 2 over 4 or 1/2. What do you think I got to do first, Brett?
So sorry, just going back to question 5.
That's fine. Go ahead.
So the y's, you have 4 on the bottom.
Correct.
2 on the top.
Correct.
So you're subtracting them like
Ready?
from the greatest number to the
Good. Now, were you trying to subtract your exponents? Because you knew the rule when you divide, you subtract, so you get a negative 2, right? So you get y to the negative 2. And I didn't want to get this deep from last year, but when you have a negative exponent, you sounded to the denominator last year to make it positive. Okay, so that's where it went. Okay. For 6, anybody know what I got to take care of first before I start reducing, Jenna?
You want to just review the exponents are outside.
I wanted to get rid of the parentheses. All right, so everyone see 2x all squared. The 2, ready? This 2 right here belongs to this 2 and to the x right there. So ready? 2 squared. 4x squared. That's what that turns into. So what do you think? Oh boy, I'm going to have to do this one for you, huh? The next one, 4 to the third.
16. Wait, no. Never mind.
64. Rubbing off on her, Brett. And then anybody remember? Raise an exponent to another one? Multiply it. So this would be 64x to the 6. So take care of the parentheses. Now we can start reducing. Now we can start. 4 over 64. Now, hey kids, surprise time here. This is why I ask you to have one of these in class every day. Do you know that your do you know that your calculator reduces for you? You don't have to think about it. Your calculator reduces these numbers for you. Watch and learn, kids, if you have your calculator out. Do you know how to get to at least the fraction template? Alpha y equals, we've been there. Kids come in and they have no idea, and it's just, you've been denied so much. So alpha y equals, get the fraction template. What am I trying to reduce on this problem? 4 over, so go ahead, 4 over 64. And watch the magic here. Woo! It reduces it for you. You don't have to think about it. All right, we can just use the fraction template, 1 over 16. And then you got to take care of the x's, so tell me what you're left and where they are. 7. What are you left with and where are they? Good stuff. Good stuff. Yeah. How did I get 64? Ready? Well, I have to see that 3 on the outside? It not only applies to the x, but it also applies to the 4. And I don't do 4 times 3. It's 4 to the third. And 4 to the third is 64. Okay? Anybody else before I get to the next one? Because this next one's a little different. Anything? Yes, Jenna.
Wait, how did you get 4 as the exponent?
How many x's you have on top? 2. How many you have on the bottom?
Oh, you said
6.
yeah.
They 2 on top and 2 on the bottom cancel each other. You're left with 4 on the bottom, right? Good questions, guys. Anybody else? Keep them coming. All right, are we ready for 7? What is so different about 7 than 5 and 6 did not have? What's that? Trinomial. And what's separating in those, what do you see in the trinomial there? You have addition and subtraction signs, right? So you cannot, everyone ready? Because I do get fired up about this, because this is a huge no-no. When you have addition and subtraction signs, you just can't start crossing off anything you want. No. All right? That was fine over here, because it didn't have a what? Addition or subtraction going on. But now it does, so you can't start pulling off, oh, hey, that's got an X, that's got an X, goodbye, goodbye. That's not flying here. Not when there's addition and subtraction. Instead, what you're going to do, and this is why we spent 2 darn days on it, guess what we're going to do to the top and the bottom? Factor, factor, factor it. All right? When you have addition and subtraction going on, look to factor. All right, top. Act like you've been here, please. What are you looking for first? GCF. Okay, what do you want to take out of the top? An X. And what are you left with? 7 minus X. All right, what are you going to try to look for on the bottom? GCF, is there any on the bottom? Nope, but you're looking for 2 numbers that do a little something. Multiply to what? 21, but add to -10. Think about it. Multiply to 21 and add to -10. When you get there, let me know. Take your time. 9. Numbers that multiply to 21 but add to -10. Casey, got him back there? You're 9, right? Oh, sorry, John. Never mind. You got him?
No.
Well, 21.
7 and 3.
Okay.
And then it's going to be plus. Wait, no. Yeah, it's plus. It's going to be plus 7. Wait, no. -7.
Good job. All right. Everyone all right with the factoring part? All right. Now it's once you're done factoring, now it's everyone's favorite time, which is you get to cross what is the same out. Okay? First of all, I cannot cross that. Here's why. When there's subtraction and addition, these two stay together. So if you're going to get rid of one, you got to get rid of the whole thing. Okay? You cannot just cross off individually when there's a subtraction sign there. So that's no good. Now here's the other problem we're going to run into. Oh, I'd love to cross those 2 out, but they're not the exact same, are they? Are they? They're not the exact same, but they are. What? Ready? What's the sign on this 7? And what's the sign on that 7? Okay, so they're opposites, right? What's the sign on that X? And what's the sign on that X? Positive, right? So these are really opposites of each other, aren't they? Total opposites. Everyone agree? These two right here, total opposites. 10 divided by -10. 10 divided by -10. -1. 6 divided by -6. 80 divided by -80. What am I trying to get at? When you divide opposites, what are you left over with? So yes, I can cross these out. But when you cross 2 opposites out, what are you left with? A -1. Now, where do I put that -1? Where does it go? It can go on top. It can go on the bottom, but it can't go in both. Anybody know why? Because if you have one on top and one on the bottom, what's that make it? Negative divided by a negative. Positive one. So just put it, where do we want to put it? Top or bottom, kids? Fine. Put it on the top. And now what's left on top now? Because I can't cross anything out. You cannot cross. Ready? Don't try to cross these X's out right here and here because that's attached by the negative sign. So what is left in the numerator? -X. And what is left in my denominator? Everyone all right? Can you cross off those X's? No. It's attached to the 3. No. We all right? I know this is not the easiest. That's why we take about 2 days to do this with an assignment. Next one. 8. a tip for you. Do you see how it says that is squared? Which means how many times is it getting multiplied? Twice. So what I would prefer you guys to do is don't leave it like that. Write it out, actually. Write it out twice. See the whole thing. Now, do you have to FOIL and stuff? No, don't do that. All right, I don't want you to do that. Just write it out twice. All right, what are you doing to the bottom? What can I do to the bottom? Because you don't want to leave it like that. There's something I can do to the bottom. Here you go, 14. What can I do to the bottom? Take out a 2. And what am I left with if I take out a 2 there, Ashley? 1 minus x. Yep. You can cross out what's the same. Ooh, I really want to cross one of each out, don't I? They're not the exact same, though. But they are what of each other? Right? -1, +1. Positive x, negative x. Excuse me. They are opposite, so I can cross them out, but make sure you're left over with a what? -1. Do you still want to keep it on top? Somehow that button gets Siri responds when I talk too loud. Where do you want to put it? Bottom? Okay. Don't encourage. There you go. Yep.
On the top part, why can't you,
Did you want to cross off these?
no,
Oh, go ahead.
sorry. Oh, why can't you distribute for the...
Okay, say the x minus 1 and the x minus 1.
Yeah.
You want to distribute that?
Yeah.
Okay, you're going, because then after you distribute, you got to factor that. And then guess where you would be back to? X minus 1, x minus 1.
I meant for like the top part in the numerator for like the beginning of the...
Yeah. Oh, you mean this? No. Oh, that?
Yeah.
No, that's no go. Because what's the difference between these where we did it and this one where you want to do it?
Oh, there's no subtraction.
Yeah, exactly. That's why I can't pull that off. All right. All right. We feel all right here, maybe? Because that's where I know it goes on to multiplying, but this is where I'm stopping. How are we? Day 2 and 3, period 5, 11:30. Okay, we're almost. So what I'll do here, I'll extend this a day. Tomorrow you'll come in, we'll get in your groups, and you'll get after it. So you don't have to worry about the assignment. The assignment's going to be a group assignment tomorrow. Everyone all right? So all we're going to do is practice this tomorrow, simplifying and undefined. We all good? Sound all right? You get your first grade of the year? Okay. Keep bringing your questions, guys. Keep bringing it. Remember, I'm here 3, 4, and 7. 3 periods, 3, 4, and 7. Don't let it snowball till next Tuesday on the quiz.